Now I think. Great, awesome. So let's continue with the chain rule. We'll do some practice and then move on. I hope you had the chance to practice some of the questions, some of the suggested questions I posted last Friday. Please try to do them. They're very important. Like, I posted some from the books. And don't try to just, do the odd ones, okay? If I post a list, I think it's worth looking at them all, trying to do them all, because the more practice you do, the better you get at this, okay? So don't try to just do the odd ones, to circumvent things. I'm already shortening it for you, okay? I'm giving you a subset of exercises, so do them all, okay? So please. Great, awesome. Now let us do this exercise. Suppose that f of 1 is 1. F prime of 1 is 2, and f double prime of 1 is 3. Find g double prime of 1, where g of x is x fx squared. How do you differentiate g? What is g prime of x? G prime of x is what? Who wants to help me? Who can help? Who volunteers? No one? Should I just do it? Derivative of x is 1. Times f of x squared plus x times derivative of f of x squared with respect to x. What's derivative of f of x squared with respect to x? It's a composition, it's a chain rule. I differentiate the inside times 2x times f prime of x squared. Let me rewrite that in a better way. Fx squared plus 2x squared f prime of x squared. Did I mess anything up? I don't think so. I think it's good. Let me find g prime of 1. I mean, I may need it later on. Oh, no, that's fine. That's fine. We don't need it. Let's find g double prime of x. What's g double prime of x? Who wants to help? Any volunteer? No volunteers? No? Yeah? Thank you. Plus
4x times f prime of x squared plus 2x squared times 2x.
Thank you. Very good. Thank you. Is that what you had? Yeah, thank you. So let's try to clean it up a bit. I mean, you don't have to, but, well, no, here you have it. Plus 4, x cubed. Oh, no, that's good. Okay, so what am I asked to find? I'm asked to find g double prime of 1. Who can help me out just immediately by looking at it? G double prime of 1. This is 6 times f prime of 1, right? You guys see this? Plus 4 times f double prime of 1. I should have picked f double prime of 1 to be 1 and f prime of 1 to be 1, but that's fine. So 6 times 2 is 12. 12 plus 12 is 24. Oh, it's not bad actually. Yeah. Is that good? Yeah? Great. Awesome. Okay, so things like that, please be comfortable with. And then let us try to see another, another way to see the chain rule. I mean, I have not introduced it this way. So, another formulation of the chain rule. I mean, it's not another formulation really, it's an equivalent one. But, of the chain rule. So, let's see. Let f be a function of u, and let u be a function of x. Right? Like u is a function of x here, right? You see that? So I have f of u of x, right? let h say, or you know what? No. Let's see, the book has a better notation for it. I think it's well, okay, so let y, yeah, okay. Let y f of u of x, okay? Then what does the chain rule say? The chain rule says that dy by dx is equal to dy by du times du by dx. So really, dy by du, what is that equal to? This is really the f prime of u of x part, and du by dx is really the u prime of x part. Okay? This is what the chain rule says. It's really, let's give an example. Let y is equal to, let's say, cosine of x squared plus 2x. We already know how to differentiate y with respect to x, okay? We already know how to do that. But let us set, so y is f of u of x. U of x is x squared plus 2x, right? So you let u be equal to x squared plus 2x. So y is equal to cosine u, right? Do you agree with this or not? Yeah? So what is dy by du? If you differentiate y with respect to u, what do you get? What do you get? Dy by du. So u is the variable here. Differentiate y with respect to u, what do you get? You get minus sine u, right? What is du by dx? Du by dx is just 2x plus 2. You agree? So the chain rule says that dy by dx is just dy by du times du by dx. Where is that? Where's the thing? So dy by dx is equal to dy by du times du by dx. What is dy by du? This is minus sine u times du by dx is 2x plus 2. Now what is u? U is x squared plus 2x, right? Is that it? Is that what I had? Yeah. Okay, is that clear? Do you guys see this? This is just a chain rule, right? Dy by du is just the derivative of the inner function, the derivative of the outer function evaluated as the inner function, right? And du by dx is the derivative of the inner function. Okay, is it clear? Any questions on this? Any questions on this? No? We're all good with this? Is this clear? Okay, great. Awesome. Now really this is more an interpretation. This is kind of, it's not that, it's more than that, but it's used for interpretation. So it says that the variation of y with respect to x is a product of two variations, right? The rate of change of y with respect to x is kind of the rate of change of y with respect to u times the rate of change of u with respect to x, right? You guys see this or not? Okay. Now, maybe it's a good time to give an application of this thing. Let's just see. So, an example, you will see more of these later, but let's start with a small, a nice example. So the side of a square is increasing at a rate of 6 centimeters per second. How fast is the area of the square increasing? When the area, or when, let's say A, the side has length, let's see, 6 centimeters, and B, when the area equals 15 centimeters. Okay, so I have a square that is expanding, okay? And the side of the square is expanding at 6 centimeters per second. You guys see this, okay? You see what's happening? I have a square, and every second, the side is increasing at 6 centimeters per second. Okay, every second, the side increases by how much? 6 centimeters. Okay, now, what is the rate of change of how fast is the area of the square increasing when the side has length 6 centimeters? Now, so let x be the side of the square. Be the side of the square, and A its area. Okay, x in centimeters, and area in centimeters. Okay, how do we relate x and the area? What's the area of a square? Yeah?
Inside square.
X squared. So A is equal to x squared. Now, I want to find how fast the area is increasing. With respect to what quantity? So A and x are functions of what here, really? A and x are functions of? Do you guys see this or not? So really what I have here, I have A of t is equal to x of t squared, where t is measured in seconds. You guys see this or not? Yeah? Now, how fast is the area of the squared increasing when the side has length 6? What do I really have to do here? How fast means, yeah? So how fast is that derivative, right? You guys see this? It's a rate of change. So I'm looking at a derivative, right? With respect to what? How fast is the area of the square increasing? So the derivative of what? The derivative of the area with respect to time, right? So what am I looking for? I'm looking for dA by dt, or a prime of t. So dA by dt. Could we differentiate this automatically? I mean, what do you prefer, the dA by dt or dA prime notation? Up to you. dA by dt. Okay, dA by dt. What do you get there? How do you get here? What is dA by dt? It's 2x times dx by dt. You guys see this or not? Let's write this in a. Let's take more steps. It's dA by dx times dx by dt. What is dA by dx? Differentiate a with respect to x. What do you get? Everybody, a with respect to x, what do you get? 2x. Times dx by dt. Another way to see this, a of t is x of t squared. If you differentiate the square root of x with respect to t, what do you get? It's 2. What's the derivative of x squared? It's 2x, right? Times the derivative of x to the t. So you get 2x of t times x prime of t. You guys see this? Or you can say this as a prime of t is 2x x prime. Okay, these are equivalent. Is this clear or not? Any questions here? Please answer. Yeah?
Where did we just inject the t squared?
x of t squared. So what is the area in terms of the side? You have the area of the square. What's the area of the square in terms of x?
Would be just x squared.
Exactly.
So how do we add this to t?
T is time. X is varying in function of time. So a and x are both functions of time. So a is a function of t, x is a function of t.
Is it just t squared or is it x of t also?
No. The whole x of t squared. Okay, is that good? Yeah. Do you guys see this now? Everybody. Any questions on this? Please do not hesitate to ask. No, we're good? Yeah? Are we good here? Okay, so when the side has length 6 centimeters, how fast is the area increasing? What am I looking for? I'm looking for a prime, right? We're looking for a prime. We are looking for a prime, or for dA by dt. When x is equal to 6 centimeters, right? And what is x prime here? Can anyone determine what x prime is? Yeah? 6 centimeters per second. Oh God, okay, I use A and B the same. Okay, great, that's fine. 6 and 6 is a bad choice, but that's fine. We have that. Centimeters per second, right? You agree? Because the side is increasing at 6 centimeters per second. So when x is equal to 6 and x prime is equal to 6 centimeters per second, what is dA by dt? X is equal to 6, x prime is 6. What is dA by dt? Can you just read it from there? X prime is dx by dt, let's say, right? This is also equal to dx by dt. What is A? What is dA by dt? Yes? 72. 72, how did you get this? Exactly. So when x is equal to 6 and we have x prime, so dA by dt, I mean it's a notation. When x is equal to 6, it's just 2x prime, which is 72 centimeters squared per second. Okay? Are we good here? Is that clear or not? Yeah, we're going to be doing a lot of these later on. Yes?
Derivative of that change.
Where?
The chain for the x.
The chain dA by dt and dA by dx, dx by dt. Yeah? What is dA by dx? If I tell you A is a function of x only, how do you differentiate A with respect to x? How do you differentiate x squared with respect to x? 2x, exactly. This is a chain rule. The chain rule says dA by dt is dA by dx times dx by dt. Okay? 2x times dx by dt.
You bring the 2 down.
Yeah, exactly. The dA by dx, I brought it down. This is 2x. Exactly. And then I have a dx by dt. Is that good? Yeah. Any questions? Are we good? Yeah. Oh, x prime is dx by dt. Prime is the number with respect to t. And then, guys, someone's asking a question, yeah? Yes, this is okay? Differentiate A with respect to t. Okay, you have this function. Okay? Let's differentiate this with respect to t. You get A prime of t The derivative of x squared, what's the derivative of x squared? It's 2x, right? So it's 2x of t times the derivative of the inside, which is x prime of t. Is that better than this? That's more, this is this, right? Okay. Great. Yes, guys, someone's asking a question.
Sorry,
Yeah.
I'm seeing a bit over here. Why is x prime also 6?
Oh, how fast the side of the square is increasing at a rate of 6 centimeters per second.
I know why x is 6. I don't understand why x prime.
Why x prime? So the size of a square is increasing at a rate of 6 centimeters per second. Okay? Is that good? This is the speed at which it's increasing. Okay, great. Yes, sir. Yeah. Yeah.
On the test, will we be expected to memorize formulas like the areas and volume?
Let's worry about this later, okay? I mean, you're supposed to know some areas. Yeah. Great. Awesome. Any questions? Great. Let's try to do part B. Okay, let's try to do part B. Is part B any different or not? Is part B any different? No. What are we given in part B? We're given the area. Great. If I'm given the area, so really, part B, well, I'll keep this one here. Part B, how fast is the area increasing when the area is equal to 16 centimeters? I.e. dA by dt, right? When A is equal to 16 centimeters squared. Now what is dA by dt? dA by dt is 2 x dx by dt. What is x in that case? If A is 16 centimeters squared, what is x? 4, right? X is 4 centimeters. So if A is 16, then x is 4. So dA by dt when x is 4 is equal to what? To 2x. So it's 2 times 4 times 6. What is that? It is just 48 centimeters squared. Okay? Is that clear?
Yes.
Yeah, everybody, is that good? We see what's happening here or not? Yeah.
So does x prime always equivalent, is it always equal to 6 centimeters?
Yes, per se. Yeah.
Given?
Yeah, that's given,
Okay,
exactly.
and then the other x and the 2x is something that is like adjusted?
Exactly. It depends on the time, basically.
Okay, so like in A it would have been 6, and in this case it's 4.
Exactly. In B, I'm not giving you x. I'm giving you A. But you have to determine x. Okay? Is that clear?
Yeah.
Yes. Okay. Great. Should we do one more or that's fine? One more, everybody? Let's do one more. Great, let's do one more. The length of a rectangle is increasing at a speed of 8 centimeters per minute, whereas its width is decreasing at a speed of 2 centimeters per minute. Find the rate of change of let's say A, the area, B, perimeter, with respect to time of the rectangle, with respect to time, when the length is equal to, what do you call the sides, length and width? Is that what you call it? Yeah. When the length of when the length equals 5 centimeters and the weight 2 centimeters and the width equals 10 centimeters. Okay. So A is the area, so we use the notation. A is the area of the rectangle. L, length of the rectangle, and W, the width, and P, it's the perimeter. Okay, now find the rate of change of the area of the rectangle with respect to time when the length equals 5 centimeters and the width equals 10 centimeters. So what is A in terms of L and W? Everybody? What is the area in terms of L and W? Everybody? Area of a rectangle is the product of the sides, right? Of the two sides, right? You see that? A is L times W. L and W are functions of what in that case? L and W are functions of time. You see that? Now, what do we need to find here? We need to find dA by dt when L is equal to 5 and W is equal to 10, right? We see this or not?
Yeah.
Great. Now, dA by dt really A prime, right? A prime is the derivative with respect to t. L and W are both functions of t here. We see this or not? So if I have to differentiate A with respect to t, what rule should I be using? Yes, someone said it, yeah? The product rule, right? We see this or not?
Yes.
So what is A prime? What do you prefer, A prime or dA by dt? Let's use A prime. A prime, what is A prime equal to? Well, the product rule says you differentiate L and you keep W fixed. L prime W plus W prime plus you differentiate W and you keep L fixed. Is that good or not? Everybody, is that good? Now, I have W. What is the value of W? W is equal to 10 and L is equal to 5. Here, what is L prime in that case? Let's try to find. L prime is equal 8. What is the unit? Centimeters per minute. L prime is 8 centimeters per minute. And what is W prime? Let's pay attention. W prime is equal to what? 2. Let's read the question very well. What is the width? The width is the width is decreasing. So W prime is equal to minus 2 centimeters per minute. Okay? Now I'm looking for A prime. We're looking for A prime when W is equal to what? W is equal to 10 and L is equal to 5. What is that? So what is L prime? L prime is 8 times 10. What is 8 times 10? Is 80. Plus W prime minus 2 times 5, right? 10. So I get 70 centimeters squared per minute. Is that right? Yeah? Okay. Is it okay? Is it good? Is it clear how to approach these types of questions? Okay, we will do more of these later. This is just, you know, a small... oh, well, we have another part. What is the perimeter of a rectangle? The perimeter is the length, right? Is the length of the sum of all the sides. What is the sum of all the sides? It's 2 times L plus W, right? P is 2 times L plus W. So what is P prime here? P prime is just 2L prime plus W prime. Well, L prime and W prime are given, so it's 2 times 6, yeah, which is 12 centimeters per second. Okay? We see that or not? Okay? Is that clear? Any questions on this? Is that okay? Yeah? Okay, so we will have to get used to this. Problems will be a lot harder than this. Okay? This is the easiest type of problem that you'll have. And we call these related rates. These are the easiest problems the easiest type of problem that you'll be able to solve. For now, I just introduced you to this. Hopefully next week we will go a bit harder, stuff like that. Okay, great. Awesome. Any questions on this? Oh, yeah.
How can we predict the derivative of P? Why did you then do like P equals
P is equal to?
well, you did like the derivative of P.
Oh, the question is that find the rate of change of the perimeter. Rate of change means the derivative. Okay?
Okay, thank you.
Any questions? No? Yes, sir. Guys. Yeah?
This question, how come you can't show the length and width and area as a function of time? Like why can't you say like the F prime is like 8 centimeters, 8 or like the area of that?
Oh, I see. So you want to do the reverse. You want to say L of t is 8 times t. That's all, and you can find the time. That you can. Yeah, I think you may be able to do that, but you have to. I mean, why is it not 8t plus 1, for example? Right? Okay. So because you just care about a prime. So okay, you may be able to do that, but you have to pay attention to this. Okay. Yeah. Per minute. Thank you very much. Thank you very much. Thank you. Great. Is this stuff here? Great. Now let's move on to implicit differentiation. Okay, so the chain rule is maybe one of the most important chapters of the entire term. So please be comfortable with this. do problems on the chain rule, and you should be fine, I think. Or maybe let's do one more on the chain rule. This is the last question on the chain rule. So let y be e to the rx, where r is constant. For what values of r do we have that? Let's see. Y double prime minus 2y prime minus 3y is equal to 0 for all x. Okay, this is called a differential equation. For those of you who are continuing in math, physics, engineering, or in science in general, you will take a course of differential equations. And these are the simplest type of equations that you'll be able to solve. So let us try to see what you will have, you may have to do later on. But let's start with this. I think this is a problem in textbook. I changed the numbers. Great. Now, what is y prime in that case? R is a constant. Y prime is r e to the rx, right? And y double prime, what is that equal to? R squared e to the rx. Y double prime minus 2y prime minus 3y is equal to 0. This implies that r squared e to the rx minus 2r e to the rx minus 3 e to the rx is equal to 0. So I can take out an e to the rx, right? Minus 2r minus 3 times e to the rx is equal to 0. And you want this equal to 0 for all x. And anyways, this can't be 0, e to the rx, so you can cancel out. So you get r squared minus 2r minus 3 is equal to 0. What are the solutions of this? R minus 1 squared is equal to 4, so r minus 1 is equal to 2. This means that r is equal to 3 or r is equal to minus 1, right? Okay? Yeah, you see that? Factor this, r plus 1 times r minus 3, right? And these are the solutions, okay? Great, awesome. Now we move on to a different section of the textbook. So let's start with implicit differentiation. Okay, so please practice the chain rule. Do some exercises. I'll be posting more problems on the chain rule. Just do them, okay? It's very important. And yeah, okay. Great. So thus far we have seen how to differentiate rules on differentiating with respect to x. The function y is equal f of x. Right? These are the rules we have seen thus far. Now, if I want to draw a curve y is equal f of x, what does the graph of f of x look like? If to satisfy a test, do you remember this test? We call it the vertical line test, right? That a vertical line cannot cross the graph more than once. You see that? Remember this? So a function, something like that, right? Can it have a loop and go back? Is this a function? No, that's not a function. Okay? Now, let us start with a nice example here. An example that you can all this is the unit circle. X squared plus y squared is equal to 1. Okay? This is the unit circle. We all know the equation of a circle, right? X squared, well, x minus the x of the center squared plus y minus the y of the center squared is equal to the radius squared. Okay. Now, this is the equation of this circle. The thing is this the graph of a function? Is this the graph of a function? No. Why is it not the graph of a function? Who can help? Yeah? It doesn't pass the vertical line test. Yeah, could you give an example for just an example why it doesn't pass the vertical line test? Yeah, so if x is equal to 0, I have two possible values of y, right? Okay. You guys see this? Yes. That's clear. Is that clear? Is it a function? No. Great. Now, if I tell you that if x is equal to 0 and y is positive, can you tell me whether this is a function or not? So let's say I restrict myself to positive values of y. If y is positive, let me restrict myself to positive values of y. Can I solve for y in terms of x? What is y squared? Y squared is equal to square root, y squared is 1 minus x squared. If y is positive, then y is equal to square root of 1 minus x squared. So really, if I restrict myself to the positive values of y, I obtain a function. You guys see this? So let's say x is, x is 1 over root 2 and y is positive. If x is 1 over root 2, then y squared is 1 half. You guys see this? Take x to be 1 over root 2. What is x squared? X squared is 1 half. Then y squared is also 1 half. How many solutions do you have for y squared is equal to 1 half? You have 2 solutions, right? Now if I tell you that y is positive, how many solutions do you get? 1. You see that or not? Is that clear? Yeah? Is that clear or not? So if x is if x is 1 over root 2 and y is positive, y squared is equal to 1 minus x squared, which is 1 minus 1 half, which is 1 half. Then y is 1 over root 2, or y is equal to minus 1 over root 2. Since y is positive, then y is equal to 1 over root 2. You agree? If I restrict myself to the positive, to a range of y that is strictly positive, then I obtain a function. Let's try to convince ourselves. If I'm restricting myself to a range of y that is strictly positive, what part of the graph am I looking at? Ignore this, you're looking at this one. Is this a function or not? You see that or not? Okay? Now, let's try to do slightly more things. If I pick a point around here, fix a point on this curve, where y is positive. And I'm asking, look just at a small part of the graph around that point. Okay? So it's a very small part of the graph next to that point. Is y a function of x in that case? Does this part of the graph pass the vertical line test? Great. Let me do this here. Does this part of the graph pass the vertical line test? I'm looking at this one. Now let me look at this one. Does this part of the graph pass the vertical line test? Okay, so far I have no problems, provided I restrict myself to very small ranges. We see that? Now, let me look at this part of the circle. Does this pass the vertical line test?
No.
No. Okay, so we have to be careful. Okay, so what we'll be concerned with are these parts of the graph. These parts where the parts of the graph pass the vertical line. Okay, so you can express y in terms of x. Okay, here you cannot do that. I mean, I guess we will not have to worry a lot about these things, but maybe for other calculus courses that you may take later on, this is going to be very important. Okay, I mean, now we're doing things in calculus. I think 3. Those will be very simple things. You just have a formula, and it takes 2 seconds to do this. But now we'll have to take the time and do them very slowly. Okay, great. So, if y let's keep this one here. I'll keep this one here. If x squared plus y squared is equal to 1, and y is a function of x, okay? Then this whole thing is a function of x as well, right? X squared is a function of x, y squared is a function of x, and 1 is a function of x. Let's differentiate this equation with respect to x. With respect to x, while keeping in mind that y is a function of x. So, what's the derivative of x squared with respect to x? Everybody? You're differentiating everything with respect to x now. D by dx of both sides. What's the derivative with respect to x of this function? X squared. What's the derivative of x squared with respect to x? This should be very easy. 2x, right? Now, y is a function of x. We agree. Y is y of x. How do I differentiate y of x with respect to, how do I differentiate y squared with respect to x? It's 2y times y prime, right? Do we see that? The derivative of y squared. What's the derivative of y squared? It's 2y prime. We see that or not? Yeah? Great. Now can you solve for y prime in terms of x and y? Y prime is, what is that equal to? This is minus x over y. We see that? We agree? Now let us look at something here. You remember we said here that the vertical line test around this point does not work, right? So if y is equal to 0, the vertical line test will not work. Now, if y is equal to 0, is this derivative defined? No. Okay, so this may be a reason for the vertical line test to fail. Don't worry about that. Okay? Yes, sir. Of y? Y squared, you mean? Yeah, so chain rule. Y of x squared. What's the derivative of this one? Y prime, okay? Thank you, and see you.